different types. We have following types of solutions we can find in a PDE here. One is complete solution or complete integral. Complete solution or complete integral. Second one is particular solution or particular integral. Particular solution or particular integral. Third one is general solution. Fourth one is singular solution. Singular solution. These are the different type of solution we can expect from a PDE. Complete solution or complete integral, particular solution or particular integral, general solution or singular solution. General solution or singular solution, that type of thing we can identify. That type of thing we can identify in a solution of PDE. Solution of PDE here. First, what is complete solution here? What is complete solution that you are going to consider here? Complete solution mean a solution of PDE. A solution of PDE which contains arbitrary constants. Arbitrary constants as many as the number of independent variable. Number of independent variable, as many as the number of independent variables. Number of independent variables of the PDE. So a solution of PDE which contains the arbitrary constants, as many as the number of independent variables of the PDE is called complete solution. It's called complete solution of the PDE. It's called complete solution of the PDE. A solution of PDE which contains arbitrary constants as many as the number of independent variables. As many as the number of independent variables of the PDE is called complete solution of the PDE. Suppose the PDE contains two independent variables here, x comma y independent variable here. The solution also contains two arbitrary constants. Two arbitrary constants, then you can say that it will be a complete solution. Complete solution. And another one is general solution, that is also similar to complete, but only one thing is different here. A solution of PDE which contains the arbitrary constants, as many as the number of, as many as the order of the PDE, as many as the order of the PDE, order of the PDE is called general solution. It's called general solution of the PDE. It's called general solution of the PDE. It's called general solution of the PDE. Both are similar structure only here. Here suppose order is 1 but number of independent variables 2. Order is 1 but number of independent variables 2 means if you are getting number 2 arbitrary constant, you can say the complete solution here. Suppose order is 1 means if you have only one arbitrary constant, then you can say that it will be a general solution. It will be a general solution. In that manner we can consider here. Therefore, sometimes this general solution can also be constructed from the complete solution. General solution can also be constructed from the complete solution. by reducing the number of arbitrary constants. In the case of you have order, the order is 1, or suppose if you reduce the number of arbitrary constants, it gives a general solution. Means we can reduce the arbitrary constant based on the some conditions. Based on the conditions, write one arbitrary constants as a function of other arbitrary constant, a function of other arbitrary constant. That is the idea we can use it. Therefore, both complete and general solution are both are similar here, and also related to each other. By writing one arbitrary constant as a function of another variable, the complete solution comes as a general solution. The complete solution comes as a general solution. That will be the idea we can get that here. Right. Note that complete solution can be converted into a general solution. Complete solution can be converted into a general solution by writing one arbitrary constant. By writing the arbitrary constants, by writing not only one, depends upon the problem. By writing the arbitrary constants as a function of some other arbitrary constants, as a function of some other arbitrary constants, as a function of some other arbitrary constants or functions, arbitrary constants or functions. With the help of that function, arbitrary constant or arbitrary function. Is in that manner we can say that a complete solution can be converted into a general solution. Then we have another one is particular solution. Particular solution is very simple only. Putting particular values to the arbitrary constant of the complete solution. Particular solution is a solution obtained by putting particular values to the arbitrary constants. Putting particular values to the arbitrary constants of the complete solution. Arbitrary constant of the complete solution. Putting particular values to the arbitrary constants of the particular complete solution. Is the particular solution. It's a solution obtained by putting particular values to the arbitrary constant of the complete solution. Such solutions are called particular solution. And finally, we have a singular solution. Can anyone have the idea about singular solution? I think you studied about ordinary differential equation in the second semester. Ordinary differential equation second semester, and different solutions here. General, particular, singular solution also you studied in the ODE, ordinary differential equation. Can anyone have the idea about singular solution from the general solution? Singular solution is nothing but it is a envelope of the family of curve given by the general solution. Envelope of the family of curve given by the general solution. General solution, we have arbitrary constant. And putting for these arbitrary constant, when putting particular values here, you can get a family of curve. You can get a family of curve here. And for this family of curve, under this family of curve, we can find a curve. That touches each and every member of the family. That is called singular solution. That is called envelope. That is also studied in the first year. That curve is called singular solution or envelope of the given family of curve here, given family of curve here. Or we can find from the general solution we can find a family of curve, okay, family of curve. Then a singular solution is nothing but that touches each and every member of the family, called envelope of the family of curve, envelope of the family of curve. Singular solution is the envelope of the singular solution is the envelope of the family of curve, envelope of the family of curve, envelope of the family of curve given by the general solution, okay? Given by the general solution. This is the idea you can get here. Y equal to mx plus a by m, or mx plus c means m is a parameter, okay? M is the arbitrary constant. That type of means you can get a family of curve here, okay? A family of curve with a different slope here, okay? A family of curve with a different slope that you can get here, okay? A family of curve of a family of straight lines with different slope, okay? A family of straight line with a different slope we can get here. Uh, Now, if you draw these family of curves from the general solution, family of straight line with a different slope here, family of straight line with a different slope. If you draw like this here, if you draw a family of straight line with different slopes, different slope here, like this here, like this. If you draw a family of straight line with different slopes. This is a straight line, and then if you draw many straight line, not only like this way, if you draw many straight line here, you see that here at one stage you can get a curve like this here, a curve like this. You see that here, this is the curve. This is the curve. It's shapes like a parabola. It's a curve shapes like a parabola. Therefore, for this family of straight lines, for this family of straight line, a curve touches. A curve touches each and every member of the family. Touches each and every member of the family. That curve is nothing but a parabola. That curve is nothing but a parabola. Therefore, this parabola is nothing but the is called as a envelope of the family of straight line like this here. Family of straight line like this here. And this parabola, this curved parabola is also called what envelope of the given family of straight line. This is nothing but a general solution. This is general solution here. Not only like this here, y equal to mx plus c, or so on here. Not only like this here. Therefore, this is a general solution. General solution for different slope value of m here. Ax plus b, or so on here. Ax plus b, or so on. For different value of a or m, you can get many curve general solution here. If you then that general solution, if you eliminate that arbitrary constant, if you eliminate the arbitrary constant, you can get a curve equation, that is a parabola equation here. Therefore, by eliminating arbitrary constant, you can get a curve like this here, that is called parabola. That is also called what singular solution. Singular solution of the given family of curves. Therefore, singular solution is the envelope of the curves given by the general solution. Envelope of the family of curves given by the general solution. Not only general solution, complete solution also you can use it. Okay? Because both are similar. General and general can be obtained from complete. For both the things we can use it. In that manner we can get that. This is the idea we can get. Therefore, these are all the different type of solution we can expect in a solution of PD. Complete, general, both are similar, and particular is by giving particular values to complete solution. But the singular solution is somewhat different here. That is a envelope of the given family of curve. Then how can we get singular solution? Already envelope idea also we know that here. Singular solution can also be obtained. Singular solution obtained by eliminating arbitrary constants. Singular solution can be obtained by eliminating arbitrary constants. Eliminating arbitrary constants from the complete or particular general solution. Complete or general solution is can be obtained by complete or general solution. Complete or general solution. That is the idea we can follow. So for that, you have to differentiate partially. Suppose we have suppose our complete solution. Our complete solution is function of x, y, z, a, comma b equal to 0. Function of x, y, z, a, comma b equal to 0. Z is function of x, comma y with arbitrary constants, two arbitrary constants. Then singular solution obtained by then singular solution is obtained by eliminating arbitrary constants, obtained by eliminating arbitrary constants from the equations dou f by dou a equal to 0 through the equations, not from the equations, through the equations. Dou f by dou a equal to 0. Dou f by dou a equal to 0 and dou f by dou b equal to 0. You have to differentiate partially with respect to one arbitrary constant and another arbitrary constant. You can get some two equations here. With the help of this equation, you are going to eliminate arbitrary constant and you are going to get the relationship here. That relationship is called what? Envelope. Envelope. Here are singular solution of the given. Singular solution can be obtained by eliminating arbitrary constant from the complete or general. For that, you have to differentiate partially with respect to a, one arbitrary constant, partially with respect to another arbitrary constant equal to 0. You can get the solution. This is the idea we can follow. Right. I think when you concentrate on the solution of a PDE, you may list out with the help of a complete, general, particular, and then singular solution. In that manner, we can calculate. Based on this idea, now we move on to the solution of first order non-linear. First order higher degree means non-linear, you can say that. First order higher degree or non-linear PDE. Solution of first order non-linear PDE you are going to see now here. Solution of first order non-linear means higher degree PDEs. First order non-linear higher degree PDEs here. In such way, we are going to see one first type here. First one, type 1 PDEs are the form function of p comma q equal to 0. PDEs are the form function of p comma q is equal to 0. Only p comma q only it will contain. Function of p comma q is equal to 0. P comma q equal to 0. For this type of PDE, by trial and error, we found that z equal to ax plus by plus c. Z equal to ax plus by plus c is the complete solution. The complete solution. This is because after many trial and error ideas here, they identified that the solution of this form here, relationship of the form z equal to ax plus by plus c that this type of solution is the complete solution of this kind of PDE. Complete solution of this kind of PDE they identified like this way. Therefore, complete solution is like this. But you know that already complete solution means where ABC are arbitrary constants here. ABC are arbitrary constant. Complete solution means it should contain arbitrary constant as many as the number of independent variable. Order means general, but number of independent variable means it will be complete. But number of independent variable here x y only. P q dou z by dou x, dou z by dou y. X only two. But here we are having three arbitrary constants. Three arbitrary constants here. For that, now we are going to minimize one thing. Now we differentiate this complete solution. With respect to with respect to x and y. From 1 dou z by dou x. Dou z by dou x is what here? A. Dou z by dou y equal to b. B implies what you can get here? P is equal to A and Q is equal to B. P is equal to A and Q is equal to B. Therefore, what about the given equation here? Given equation is f of p comma q equal to 0. Now p equal to A, therefore q equal to B. Therefore, from the given equation, under this complete solution idea, we have a relationship between A and B is f of a comma b equal to 0. With the help of f of a comma b equal to 0, you can write b as a function of a. For a and b as a function of a, it is also a. Therefore, only one arbitrary constant here, and one more arbitrary constant c. Therefore, in that manner again, write again. Therefore, p equal to a, q equal to b. This gives f of a comma b is equal to 0, since given equation is f of p comma q is equal to 0. F of a comma b is equal to 0 means you can write b as a function of a. Therefore, complete solution is of such kind of PDEs ax plus pi of a y plus c. Where a and b are arbitrary constants. A and b are arbitrary constants. Where a and b are arbitrary constants. Therefore, for this kind of PDE, your complete solution can be written like this. Now, when you concentrate on general solution of this kind of PDE, already you know that general solution means general solution can also be obtained from complete solution. This is complete solution. General solution means it should contain arbitrary constant as many as the order of the PDE. Order of the PDE is first order. P comma q first order only here. Therefore, it should contain only one arbitrary constant. This is A is the arbitrary constant. Therefore, if you write C also function of A, you can say that it will be a general solution. If we write or if we put C is equal to also some other function of A, psi of A in the complete solution, comma, we get general solution. Z equal to ax plus pi of a y plus psi of a. Ax plus pi of a y plus psi of a. Ax plus pi of a y as psi of a. This will be general solution, because general solution should contain arbitrary constant as many as the order of the differential equation. Order of the differential equation is one only, first order. We must have only one arbitrary constant. Therefore, again write C as a function of A here. Then you can say that it will be a general solution. Particular solution is by putting particular values to the arbitrary constant. Now, further we move on to singular solution. Singular solution means differentiate here two arbitrary constant. Complete solution we can identify here. differentiate partially with respect to A, partially with respect to C. Okay. Singular solution you can identify. Particular is that is a different idea. We put particular values to, that is depends upon the problem. Singular solution, already complete solution is z equal to ax plus pi of a y plus c, c, where a and c are arbitrary constants. Are arbitrary constants. Uh, Therefore, differentiate implies dou z by dou a we require here. Dou z by dou a is equal to uh, with respect to a you have to differentiate partially here. Therefore, equal to x plus pi dash of a y. Pi dash of a. Similarly, dou z by dou c. Dou z by dou c equal to 0. Sorry, dou z by dou a means here there is no a, therefore you have to put 0. Left side is 0. You are right like this. Similar dou z by dou c also 0 here. Differentiate, this is 1. Partially with respect to a, with respect to a. Therefore, it is equal to 0. There is no a, 0. Here a is there. Here there is no a, 0 here. Okay, right like this. Similarly, differentiate 1 partially with respect to c. There is no c, 0. No c, 0, 0. But here c, 1. 1 equal to 0 is a wrong conclusion. This is absurd one here. This is totally a contradiction one here. 1 equal to 0 here. Therefore, when you differentiate partially with respect to a, partially with respect to c, partially with respect to c, we are getting a wrong conclusion here. Therefore, which is a wrong one. Therefore, this kind of PDEs, do not have a singular solution. Do not have a singular solution. That is, singular solution is impossible for this kind of PDE. Singular solution is impossible. Singular solution is impossible for this kind of PDEs. We are getting a wrong conclusions, wrong ideas here. Or for this type of problems, PDEs, you do not have any what singular solution. Singular solution. Yes, all of you understand here. For f of p comma q is equal to 0, after many trial and error ideas here, they identified that z equal to ax plus by. See that here z equal to ax plus by plus c is the complete solution. But because of this PDE, we are getting p equal to a, q equal to b based on this complete solution. Therefore, this b can be related as a function of a with the help of the given equation. You have to replace all the p and q by a, b. Then you can write b in terms of a here. Therefore, you can get required complete solution, proper complete solution. In that complete solution, you replace c also a function of a, you can get general. Singular solution is impossible. Particular is it is depends on your choice. Depends on your choice. This is the idea we can follow. This is f of p comma q is equal to 0. F of p comma q is equal to 0. Now we can take some problems based on these ideas here. Solve the following PDEs here. Square root of p, square root of q is equal to 1. Square root of p, square root of q is equal to 1. What about your this is f of p comma q equal to 0 here. F of given square root of p plus square root of q is equal to 1 of the form f of p comma q is equal to 0 here. Only p comma q only present. Therefore, can write complete solution as z equal to ax plus by plus c. Z equal to ax plus by plus c, where a and b are related by f of a comma b equal to 0. Okay. Whereas we have to reduce one constant, that you can use f of a comma b. F of p comma q equal to this one. But f of a comma b equal to 0 means root a plus root b is equal to 1. Substitute in the given equation. Therefore, root b can be written as 1 minus root a. Squaring both sides here, it will be 1 minus root a square here. 1 minus root a square here. That type of thing we can get there. For b can be written as 1 minus root a whole square. B equal to 1 minus root a square. Therefore, complete solution is z equal to ax plus b is 1 minus root a square y plus c plus this will be your complete solution. Only two constants here, a and c. A and c. Root pq means what, dou z by dou x, dou z by dou y here. Therefore, only two independent variables here, two arbitrary constants. So, in order to reduce one arbitrary constant, we can use the given equation. From that, you can write one constant in terms of other arbitrary constant. General solution is very simple. Just to put c is equal to pi of a. C is equal to pi of. General solution is very simple. Put c is equal to pi of a or psi of a in the complete solution. Then general solution is z equal to ax plus 1 minus root a whole square. C is a pi of a. C is a pi of. Only one arbitrary constant. This pi of a you can identify whether it is what is the value. This pi of a you can identify exactly when you know boundary or initial conditions of the PDE, and you know the boundary and initial conditions of the problem. In that case, you can know what is exactly pi of a. What is exactly pi of a, that you can identify. Singular solution is impossible for this problem. Singular solution is impossible. It is impossible for this problem, for this kind of problem, because it is of the form f of pq equal to 0. Therefore, it is impossible for this kind of problem. In the same way, we have another problem. Solve p square plus q square equal to npq. P square plus q square equal to npq. Npq. Previous problem over for all of you.
Yes, sir.
Yes. It is also the form f of pq. N is some number or so on. F of pq of the form. Right. Right. In the solution, given PDE, p square plus q square equal to npq is of the form f of pq equal to 0. F of pq equal to 0. Therefore, you can write complete solution. Therefore, complete solution always you can write ax plus by. Ax plus by plus c. Ax plus by plus c, where a and b are related by f of a comma b equal to 0. F of a comma b is equal to 0. We replace b by a and q by b. For a square plus b square equal to nab. A square plus b square equal to nab. But you would write either b or a in terms of another variable here. So, it is like a quadratic equation: b square minus nab plus a square equal to 0. As a quadratic equation in b. In b, like you can write b in terms of a, b equal to minus b plus or minus root b square minus 4ac by 2a. A is 1. A is 1. A1, this is b, this is c. C is equal to a. For na plus or minus, I can take it. I can take it as a square, or leave a square here, a, and square root of n square minus 4, n square minus 4 by 2, n square minus 4 by 2. Therefore, you can write b is in terms of a here. B is in terms of na plus a into square root of n square minus 4 by 2. Or you can write b like this. You can write b like this. Therefore, from this you can write complete solution. Okay, you can write complete solution. Therefore, complete solution is z equal to ax plus by plus c, that is equal to ax plus b is this one here, na plus or minus a into n square minus 4 by 2. This is b into y plus c. No, this is ax ax plus b now can be written in terms of a, by plus c is the complete solution. Put c is equal to pi of a, we can get general, no singular solution. Put c is equal to pi of a, we can get general solution. We get general solution and no singular solution. No singular solution. In order to write b in terms of a or a in terms of b, you can write a is also in terms of b, no problem here. Any one of the arbitrary constant you have to reduce. You have to reduce here. Or it is like a quadratic equation in b. We can proceed further. I can proceed further. The same way, you try and give the answer for this problem here. Solve following PDEs. Simple problems only. Q square minus 3q plus p is equal to 2. And second problem is q plus sine p. Q plus sine p is equal to 0. Q square minus 3q plus p equal to 2. Second problem is q plus sine p equal to 0. Please all of you try and give your answer. Both are f of pq form. F of pq equals 0. Answer over. For the first one, our complete solution is
ax plus
hmm,
3 plus or
A,
minus root 9 minus 4a by 2 into y.
okay, plus C. Okay.
Yes, sir.
For the second problem, your B value equal to minus sin A, va?
Yes, sir.
Minus sin A. For your complete solution will be Ax minus sin A into Y plus C. Minus sin A into Y. Yes, I think all of you completed that two problems here, and we move on to another type here, type 2, separable equations here. Type 2 is separable equations. Yeah, first order PDE is said to be separable. Said to be separable if it can be written as, if it can be written as f of x comma p, function of x comma p equal to function of y comma q. We can split x and p one side and y and q another side. If you are able to split x and p one side, y and q another side, then you can say that it will be a separable PDEs. The first order PDE should be a separable PDE. To get the solution here, to get solution, let f of x comma p, after splitting this one like this here, you have to put it as some a say, some arbitrary constant a say here. Implies you can get f of x comma p is equal to a, and g of y comma q is equal to a. Okay? From this you can write p as a some function of x comma a. Okay? And similarly from this you can write q as a some other function of y comma a. Okay? Y comma a. You can write p as a y x comma a, y comma a. And and we know that by total differentiation method, okay? By total differentiation, dz can be written as dou z by dou x into dx plus dou z by dou y into dy, okay? Z is depends on x and y. In that case, total derivative of z can be written like this here: dou z by dou x dx, dou z by dou y. This is nothing but p. This is q. This is q. This is q. Therefore, we can write dz as p dx plus q dy, q dy. But you know that now p can be written as x comma a, y comma a from here, p and q. Or p can be written as function of x comma a dx. Q can be written as function of y comma a dy here. This is z. But we are need a z only here. Therefore, integrate implies z can be written as function of x comma a dx plus integral function of y comma a, y comma a dy, y comma a dy, plus an arbitrary constant, plus an arbitrary constant c you can put. Therefore, if you integrate, this is a relationship between ax, ay here, one arbitrary constant, one more arbitrary constant. Therefore, we have two arbitrary constants, a and c. Therefore, we can say that is the complete solution. Is the complete solution. Put c is equal to some other function. C is equal to some h of a, gives general solution. General solution here. In the complete solution, one extra c, additional c is there. Therefore, like a previous problem, previous method, singular solution is impossible, and singular solution is impossible. Singular solution is impossible for this type. Impossible for this type. Singular solution is impossible for this type. Here is also, here c is a separated one. Therefore, in differentiate partially with respect to c, partially with respect to c, you can get 0 is equal to 1. It is observed one here. Therefore, it is not suitable. Yeah. For very simple idea, for separable equation, you assume after separation, x comma p one side, y comma q another side, you put equal to a. From that equation, this one and this one, you write p and q, write p and q. Then complete solution obtained from integral p dx q dy. That's all. P dx plus q dy plus c, plus c. What is p? What is q? Right there here, you can get the relations. That is complete. Then put c is equal to pi of a or h of a or anything. You can get general solution. General solution. Singular solution is impossible for this type of problem. Idea is very simple. Solve some example problems here. Solve p square y into 1 plus x square equal to q x square. P square y into 1 plus x square equal to q x square. That type of thing you can get that. Solution given PDE is p square y into 1 plus x square equal to q x square. You have to get p and x one side, q and y another side here. Therefore, p square 1 plus x square by x square equal to q by y. Q by y equal to some a, say a separable equation of the form of separable equation. In this you club equate these two, this one and this one. P square into 1 plus x square by x square equal to a, and q by y equal to a. From this you have to identify what is p, what is a, what is q. P square equal to a x square by 1 plus x square, and q is equal to a y. P equal to square root of so on here. That is p equal to square root of ax, ax whole divided by square root of 1 plus x square, and q equal to a y, q equal to a y. Therefore, complete solution from the total derivative idea, integral p dx, integral q dy plus c, integral p dx plus q dy plus c, p square root of a x square root of 1 plus x square dx q dy plus c. Here put 1 plus x square as a t, 1 plus x square as a t, then 2x rt is 2x dx is equal to dt, 2x dx is equal to dt. it is as usual only here, and then you can get square root of a 2x dx is a t dt, therefore dt by 2 by square root of t, and a y square by 2 by 2 t power 1 by 2, therefore t power 3 by 2 by minus 1 by 2 t power 1 by 2 by 1 by 2. This is power minus 1 by 2, minus 1 by 2 plus 1 by 1 by 2 plus 1. Therefore, we can get to t power 1 by 2 by 1 by 2 plus a y square by 2 plus c. A square by 2 plus c. So 2 get cancelled, 1 by 2 get cancelled here. Therefore, this is root a t, root a t, root a t plus a y square by 2 plus c. Whatever t, root a into t is 1 plus x square plus a y square by 2 plus c is the complete solution. Contains only two arbitrary constants a and c. Put c is equal to pi of a, we get general and no singular solution, and no singular solution for this type of problems. This type of problem. No singular solution for this type of problems. Okay. Idea is very simple only here. You can able to split px one side and qy another side, and then after that splitting that one, you can say it will be separable equation. Therefore, try to identify what is p, what is q. By identifying p and q, the complete solution is given by pdx qty plus c, and then you can substitute here and then solve the integration. Solve the integration. This is the idea, can get it. And the help of the same idea, the two problems for your exercise solve by separable equation idea. P square plus q square equal to x plus y. This is second problem, and third problem is p minus x square equal to q plus y square. Q plus y square. We can separate p square minus x, q square plus y minus q square. Already in separable equation form only. Separable equation form. We can proceed. We can split here px one side, qy another side, and put a equal to a equal to a. You can get answer. The idea is very simple. I think you can get the answer for the remaining two problems here easily with the help of separable equations here. Separable equation. Can you give the answer for the first one? First one. P square plus q square equal to x plus y. P equal to square root of
A plus X.
a minus x. Then proceed. Idea is very simple only. A minus x whole power 1 by 2, 3 by 2 by 3 by 2 with the minus sign. PDX q dy, integral PDX plus q dy.